2008 was a year of tragic headlines. The terrible Sichuan earthquake in China. The horrifying cyclone Nargis in Myanmar. Exploding volcanoes. Killer tornadoes.
Look at the house!
And dire climate change. But lost behind those grim headlines came electrifying scientific breakthroughs. New ways to see into our violent Earth, its skies and seas, and predict the unpredictable. Discovering new creatures, helping others in trouble, and designing glimpses of a smarter future, a gentler partnership with our surprising planet. From space, it is the picture of serenity. An inviting, tranquil, fertile ball that any would be happy to call home. But peer beneath its sliver of crust, and the throbbing red heart of planet Earth reminds us of its violent birth. And a legacy of that violence continues today. The Earth beneath our feet is actually careening around the globe. Continents crash into each other and crack and slip and explode. And last year, the toll was immeasurable. But tragedy has spurred science closer to a great leap forward. How to predict disaster and save lives. On May 12th, in China's western province of Sichuan, the Earth began to shake. A catastrophic 7.9 magnitude earthquake ambushed the mountainous poor region. The violent tremors could be felt nearly 1,500 kilometers away in Beijing. It was the most devastating disaster to hit China in over 3 decades, leaving 70,000 dead. And nearly 5 million homeless. Heartbreakingly, thousands of the dead were students, trapped in the rubble of shoddily built schools. There had been no warning, even though China has long been looking down the barrel of a tectonic gun. India, once a lone giant island, has been grinding against Asia for 50 million years. Thrusting up the Himalayas and shattering the lands in its way, especially the vast expanse of China. Alarmingly, post-quake research showed that the quake may have actually increased the likelihood of future catastrophes by ramping up the stress on neighboring faults. Although the central region of China is a very seismically active zone, the Sichuan earthquake came as a surprise. Before May 12, 2008, no major earthquakes had occurred along that particular fault in over 1,000 years. In the wake of Sichuan, earthquake prediction, the holy grail of geology, has become an even more urgent worldwide mission. One intriguing theory came from Taiwan, where researchers have found that almost all quakes on the ground are preceded by electrical disturbances in the atmosphere. Apparently, when rocks are compressed before a quake, they act like batteries, producing electricity. Scientists hope to design an early warning system based on this remarkable phenomenon. Another breakthrough comes from a famous quake zone half a world away, Southern California. Here, geologists inserted seismometers and sensors into several holes drilled 1 kilometer deep into the San Andreas Fault. For the first time, these instruments recorded stress-induced changes in rocks, hours before tremors could be felt along an active section of the fault line. And there's a lot at stake for the residents of the most populous region in the United States. In November, the U.S. Geological Survey released a frightening projection of the destruction a 7.8 magnitude earthquake would inflict upon the California coast, killing 1,800, injuring 50,000, and causing upwards of $200 billion in damage. This is not idle speculation. New calculations indicate a 99% chance of an earthquake of 6.7 magnitude or greater occurring in California in the next few decades. Earthquakes, of course, are not the only violent hallmarks of a restless planet with a roiling red heart. In 2008, 64 volcanoes erupted worldwide. There's a great deal at stake. 1/10 of the Earth's population lives in the shadow of the world's 1,500 active volcanoes. Predicting exactly when an eruption will occur has always been a bit of a guessing game. But now, University of Pittsburgh scientists may be on the way to cracking the code. Using NASA satellite images, they can spot the first signs that the active volcanoes are heating up. Then it's time to take the volcano's picture up close and in living color. Before a volcano erupts, hot magma rises toward the surface, lighting up the mountain on infrared imaging, as with this amazing picture of the infamous Krakatoa. But the real breakthrough came with the volcano in far eastern Russia. Its color portrait led the scientists to predict the eruption 6 days before it happened. 6 days can save a lot of lives. Volcanoes are killers, but we may owe our lives, all life in fact, to them. Thanks to this spectacular phenomenon, volcanic lightning. Last year, after a 9,000-year slumber, the Chaitén volcano in Chile woke up with a bang and a light show. Toxic ash and dust ionize particles in the air, which ignites an electrical storm. This may have been the spark that lit up the Earth's primordial soup with the chemicals of life. Not all volcanoes generate lightning. Simple lava flows are not enough. You need the smoke and ash. Chaitén's temper tantrum hurled tons of ash and gas over 15 kilometers into the air. The plumes, as seen from space, reached far across South America and into the southern Atlantic. Though the smoke made the air difficult to breathe, contaminated well water, and smothered crops and farmland in the area, some scientists believed there might actually be a benefit.